So let's go ahead and take a look at two problems that involve dependent relationships or independent relationships to see how it affects our probabilities here, how we calculate them. And so looking at this first question, the probability of obtaining 5 tails in a row when flipping a coin. What's the probability of getting that? So what we're really asking for is the probability of getting 5 tails. Now, what we know is the probability of getting 1 tails, right? Getting 1 tails is 1/2. And so the probability of getting 5 tails is the same as the probability of getting a tail in the first one and the second one and the third one. It's what we call or I call in lecture, a sequence of events. And so in this case, your answer is just 1/2 times 1/2 times 1/2 5 times, because the probability of getting the tails in the first one has no influence on the second one, no influence on the third one. The coin doesn't remember what it flipped. And so in this case, as a shortcut, we would say 1/2 to the power of 5. And so that's the probability of getting 5 tails in a row. And so to calculate that, we could do 1/2 raised to the power of, let's go that outside, raised to the power of 5. And so you get 0.031. In that case, that's the probability there. 0.031, or about a 3.1% chance of that happening. Consider this event, considering this is this, and we repeated it 10,000 times, it's expected that the event will result in 5 tails. And so in this case, you just take your 10,000. If you did that, you would multiply it by 3.1%. So in this case, we're looking around, when you multiply that, 3 out of 100 or 30 out of 1,000, this would be 300 out of 10,000. So around, multiple that, 1, 2, there's 4, so 1, 2, 3, 4, around 310 times we would say we would expect that to happen. The next question's related to this. 18% of the population is nervous around strangers. If 2 people are randomly selected, what is the probability they're both nervous? It's the sequence of events again. What's the probability that they're both nervous? Right, the sequence of events when we have these independent events. And so this would just be equal to 0.18 times 0.18. Or we would say 0.18 squared. And so that would be our answer there. If we did 0.18 squared, you get 0.0324, which is 0.0324, 4 decimal places. So that's where we got there. I messed up here. This is 5 decimal places, so just be mindful of that one. I think it was 0.01325 if I would remember correctly. The probability of at least 1 is nervous around strangers is an important question here. Now, out of these 2, what we learned in lecture is the probability of at least 1, right? It's going to be 1 minus that, the probability that they both are nervous. So at least 1 is nervous. Let's do this again. Let me clarify this here. The probability of at least 1 being nervous, at least 1 nervous. Not that 1 is nervous, but at least 1. So that could be 1 person or both people. We know the probability that both are nervous is 0.034. The probability of at least 1 nervous is 1 minus the probability that they're both not nervous. That's a not there, that they're not nervous. So in this case, it's 1 minus, and I'm going to say 0.82 squared. Now the 82 comes from because 18% of the people are nervous, 82% are not nervous. And so that's where that comes from. 1 minus 0.18 is 0.82. And so this is the not nervous people. And so you want to keep that in mind. And so in this case, our answer would be 1 minus 0.82 squared. And so you get 0.3276 for decimal places. 0.3276, if I got that right. There it is.